Okay, so this is the second part of 0.9. I just decided to do a couple more examples to give you more variety on related rates. Number 32 is 253. A kite 100 feet above the ground moves horizontally at a speed of 8 feet per second. What rate is the angle between the string and the horizontal decreasing when 200 feet of string has been let out? So we have a kite that's moving horizontally, and we have an observer, the string and the horizontal. Okay, so this is the string and this is the horizontal, and we know the kite is 100 feet high, so that's fixed. That's theta. We're looking for the speed of, so if this is x, then dx by dt is 8 feet per second, because that's the speed of the kite. At what rate is the angle of the string between the string and the horizontal decreasing? So what's d theta by dt? And they're saying decreasing, so we expect the answer to be negative. When 200 feet of string has been let out, when 200 feet of string have let out. So basically when y is 200, that's when they're looking for. Right at that instant. But remember, that's not, if this is y, so when y is 200, y is changing here, okay? So I don't want you to think it's always 200. But right at that instant, what's the rate of change of the angle between the string and the horizontal? Okay, so what I did, I found a formula that relates theta, because we need d theta by dt with the opposite and the adjacent to theta. Tangent is opposite over adjacent, which is 100 x to the negative 1. So differentiate. I'm following the steps for related rates. Derivative with respect to theta of 100 x to the negative 1. Sorry, with respect to t. Why did I say theta? I don't know. Related rates, always you differentiate with respect to time. So that's going to be secant squared theta times derivative of theta with respect to t. That's going to be negative 100 x to the negative 2 times x by dt. So secant squared theta times d theta by dt equals negative 100 over x squared. So I move this to the bottom, dx by dt. And now we want to, this is the unknown, so we want to figure that out. We don't have theta, so we need theta or cosine theta to get secant, because secant is 1 over cosine. So we don't really need theta, we need cosine theta. And we have dx by dt, and we don't have x, we have y. So we gotta find cosine theta and we gotta find x. Okay. So when y is 200, cosine theta is adjacent over 200. So actually we don't even need, look what we can do. We can write cosine squared theta equals x squared over 40,000. If you square 200, you get 40,000. So if you put this in here, I don't even need, let's see what we get. I'm not going to say anything. So secant square is 1 over cosine square. So if this is cosine square, then secant square is 40,000 over x squared. If you put that in there, you get 40,000 over x squared d theta by dt equals negative 100 over x squared dx by dt. There's no need for x because we can times by x squared. It's going to cancel out. So d theta by dt is negative 100. dx by dt is 8. And divide by 40,000. So d theta by dt is negative 0.02 radians per second. Okay. So that's 32. The last one that I want to do is 48 from page 254. From page 254. Let's see what's in there. A ferry wheel with a radius of 10 meters is rotating at a rate of 1 revolution every 2 minutes. How fast is a rider rising when his seat is 16 meters above ground level? So if we have a ferry wheel, so we know that the radius is 10 meters. We know that the radius is meters. It's rotating at a rate of 1 revolution every 2 minutes. 1 revolution every 2 minutes. So it's half or 0.5 revolution per minute. That's the rate. 0.5 revolution per minute. How fast is a rider rising when his seat is 16 feet above ground? How fast? So a rider when his seat is 16 meters above ground. So if this is ground, there's 10 meters, so to be 16 you need 6 more, right? This is 10. So basically we're talking, if he's right here, that should be 6 meters. And this is x. So we want to know how fast is a rider rising. How fast is a rider rising? So we need dh by dt. We need dh by dt. Okay, if this is h. So right when h is 6, we can use the Pythagorean theorem. X squared plus 6 squared equals 10 squared. So x equals 100 minus 36 is 64. So x is 8 meters. Right when h is 6 meters, x is 8. So if this is theta, you know this is rotating at a rate of 0.5 revolution per minute. So sine theta, again we're using sine because it relates opposite over hypotenuse, h over 10. So h equals 10 sine theta. So dh by dt is 10. Derivative of sine is cosine. Chain rule says I have to do d theta by dt, which is 10. Cosine is adjacent over hypotenuse. When h is 6, x is 8, so it's 8 over 10. And then d theta by dt, we get it from there. It's 0.5, half a revolution per minute. Half a revolution, you see 1 revolution is 2 pi radians. Half revolution is a pi radians, okay? Half a circle. So we're doing, 0.5 revolution per minute, that's pi radians per minute. That's what d theta by dt is, right? So it's pi. So it would be 8 pi